Now, would the left and right limits be the same if x was approaching 2? Would those
No.
limits?
Let's look at that. Oh, I'm sorry. Yes. Yeah. Sorry. We'll take 1, 2, 2.
Well, no, I meant the two that's not marked on the graph.
Oh, you're saying if this thing was hitting there?
Yeah. Would that still be the same limit?
Yeah.
Okay.
That was our first example.
Okay.
Example, we made a hole, right?
Yeah. Okay.
That's correct. If this thing were shooting out of here like this, then yes, they would both be 2, right? And the overall answer here would be 2. That's correct.
Okay.
Right? But since, hold on 1 second. Since I misunderstood you for a second, I want to go ahead with that example. There. So now I want to know that, we will say that that's also height 2. That dot is 2, 2. So what is the limit of f of x as x approaches 2 from the right? 2. What's the limit of x as x approaches 2 from the left? 2. What's the overall limit as x approaches 2? 2, right? This whole thing over here, if you saw something like this and then talking about this piece over here, then that means what? That this whole thing over here is what you call a big fat red herring, right? Meaningless to the whole problem. I'm only examining what's happening around 2, right? All this talk of limits, which we're going to be very imprecise about, we're not being mathematically precise here, right? All this talk about limits is really talking about some minuscule little window around 2. Matter of fact, that window is as small as you like, right? So I don't care what's really going on out here in the bigger picture of the whole function. It doesn't matter at all. All I care was going on microscopically around the number 2 in this context, or microscopically around 0, okay? Infinitesimally close to these numbers, all right? That's all we really care about with limits. All the rest is that red herring. You guys know what red herring is? What's that?
Lost clue.
How do you know that? Sherlock Holmes? Well, I guess Harry Allen Poe because we're so close to Baltimore or something. I guess Holmes. Any questions about right and left-hand limits? Sure. Okay. Another quick example. I just want you to example as concrete as possible. Never seen this before at all. Let's say that's all the function is right there. That little half a parabola, right? Go back to 0 again. Favorite number. What's this one? Limit of f as x approaches 0 from the left.
0. I mean 2.
2. I know what you meant. What's this one? That doesn't really there. That's a shame.
Does not exist.
Right. There's no approach. No approach there, right? Okay. So what's the last one then?
2.
Clearly D and E, right?
Oh.
If either
Oh,
one of
that's
these
right.
two doesn't exist, then the whole thing doesn't exist, right? Because it must be the same, right? These two must be the same for the overall limit to exist, right? I'm crushing this. All right, now we want to actually compute these puppies. All right, this was just fake notions of what these things are. Now let's see some practical algebra applied to these things. You shouldn't take limits lightly. They are the foundation of all of calculus. There's no derivatives without limits. There's no integrals without limits. The whole thing is one giant fat limit. on this function. 1, 2 is a hole, right? Take the back off. Don't big fat things today. Thanks. I would like to describe this function. I'm going to write an equation for this function. Or I should say the rule. I want to write up the algebraic rule for the function. So it feels like it's a line with a hole in it. This is a very common situation in a class like this that have lines and holes in it. It's a very common problem. You may not realize, I want you to realize from the outset that some of the problems you're dealing with are lines and holes. Okay? A lot of times you're just doing a lot of algebraic techniques and you don't realize the geometry behind them, you don't realize that there's a line in the hole. So if we construct the algebraic rule for this function, that will give us an example of a very commonly occurring type of function you're going to have when dealing with limits. Okay? So, help me. How will I describe this thing? Yes? What's the last name? Lou, right, Lou. Lou says this is the function x plus 1. And he's basically right. And that's the line part of this line, right? In other words, every single location on this curve, on this line, every single location here is described by x plus 1, except for the hole where the function is undefined, correct? Mm-hmm. Every other location on this line is x plus 1. Now, how do I throw the hole into this picture? I need to make this thing recognize. I need to make the algebraic expression here recognize there is a hole here.
Yeah.
No. That makes the domain understand that 1 is not allowed in here. I want to make the algebraic expression understand that the number 1 is not allowed in here. What's that? No, you're going for sets. You're going, no, I want the algebra. I want this expression here. You are correct, Cornejo. The domain of f is all reals except for 1. That is true. But I want an expression containing the variable x to say that in and of itself. Does that make sense what I'm saying or not? Not at all.
I can understand what you're saying.
Gary. Say it one more time.
Try the equation having a fraction where if x equals 1, the denominator is 0.
Let's substitute.
Like that?
Yeah, but now you have to make it equal the same thing. So I guess.
Now I have to do what?
I don't think that would be the same line.
You are correct. X plus 1 or x minus 1 is not this. But you are very close.
X squared minus 1?
X squared, what did you say?
Minus 1?
Very good. How'd you know that?
I multiplied